to the second episode of Adventures in Knowledge. Today we're going to continue climate change and talk about misconceptions. Let's start with something fun. Cows! The reason I've taken you to see cows is because of a belief that often detracts from the important issues that should be discussed when it comes to climate change. Some people believe that cows' farts give off too much methane gas and are a major contributor to climate change. Yep, you heard me right. Farts. Cow farts. Some even say that scientists want to get rid of and destroy cows in order to combat climate change. So let's set the record straight. One, no, scientists do not want to do that. Maybe some random weird scientist out there, but no, the majority don't. No one's against cows, okay? We're not. We're just not. The truth is that cows do burp and fart methane gas. Burping more than farting, actually. Their farts contain less methane than their burps. Or maybe they burp more than they fart? Honestly, I don't remember what I read now. It's one of the two. Anyway, this is due to their digestive tract and the fact that their diet is made of grass. Honestly, this should just be an interesting fact to know, not one that causes actual concern. The truth is that cows and other livestock do produce 37% of methane gas in the atmosphere. But let me explain to you why that's not a big concern. With a pie chart. Sorry, this way.
The methane produced by animals does contribute to climate change. However, in 2018, the stats showed that carbon dioxide was 81% of the gases contributing to climate change, while methane was only 10%. This means that cows contribute 3.7% to the planet's climate change.
Small sidetrack, let's look into how fossil fuels form, what they are, and how they affect climate.
They form when organic matter such as plants or animals or fungi that have been buried deep in the ground are exposed to heat and pressure for millions of years. The pressure and heat turn the decomposing material into oil or gas.
Coal is formed in the same way, but it is made of plants, not animals. These fossil fuels, when used, give off a lot of CO2 as well as other gases such as methane.
Fossil fuels are mostly carbon and hydrogen. Because of this, when burned, the carbon binds to oxygen, forming CO2, and the hydrogen bonds with oxygen to form H2O.
The CO2 produced is entirely dependent on how much carbon is in the fuel. This is why natural gases create less CO2 than coal, while producing an equal amount of energy. Coal has more carbon. Okay, back on track. Another inaccurate belief, and likely the biggest one people have when it comes to climate change, is the idea that mankind is not the cause of it. So let's look at the evidence, shall we?
To begin with, the Earth can reflect some of the sun's rays, while others get absorbed and heat the planet. This is why some people believe that humans are not a cause. However, the pollution and other exhaust humans have created since the Industrial Revolution have increased the CO2 and methane in the atmosphere. This blocks more and more sun rays from being able to escape the Earth's surface.
How do we know this? Scientists observed the number of sun rays hitting the Earth and found that there is no significant difference in the amount from thousands of years ago, which means we aren't actually getting more sun than we did in eons past. What has changed is the amount of heat that is able to leave the atmosphere. Also, recently the sun has actually cooled a bit, so we're getting less heat from it. Our world temperature, however, is still rising. There was one time, however, in human history where this occurred without human involvement, so we'll go over that.
The Permian extinction, which occurred 252 million years ago, also involved the greenhouse effect during which heat was trapped in the atmosphere. The difference was, the world was covered in many more volcanoes than it is today, and as many of these erupted, they released CO2 into the atmosphere. This led to changes in water pH and air quality. The ocean life died due to the change in pH. In addition, the anaerobic bacteria and algae in the water flourished, producing toxic gases that led to deteriorating air quality. Consequently, many land animals and plants began to die.
This was the largest mass extinction the world has ever seen. The extinction of the dinosaurs pales in comparison to the Permian extinction. Around 96% or 95% of sea life died, and around 75% or 70% of land life died. So 96.4% or 95.4% of life died in the Permian extinction versus 80% or 76% during the age of the dinosaurs. The higher percentage is the National Geographic data, and the lower percentage is Encyclopedia Britannica. Either way, it is a massive difference in lives and species lost. It's 16.4% or 19.4% more species extinction during the Permian extinction than it was in the dinosaur extinction. So, yeah, it was a bad extinction. Worst on record. Learned about that in school with my degree. I'm not doing anything with, except for this, that I'm doing this with. Ugh, my voice is a little crackly. Sorry about that. I have no idea what's going on with my voice. Yeah, and I know my glasses are really reflecty. Not bad. I could have worn my contacts, but Ugh, contacts. Sometimes I do, like for karate, but they made my eyes so itchy. Anyway, sorry, sidetracking. Not even on anything interesting. Anyway, and yes, that was a lot of percentages, but seriously, I just need you to understand. The Permian extinction was super duper 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 massive. Okay. Well, this is the only event we know of that relates to how the world is getting hotter today with rising CO2 and greenhouse effect. Briefly, let's address other events that impacted climate without humans, so we get a better understanding and idea of why scientists say that current climate change, or global warming, is human-caused. Other events in world history that relate are, for instance, the Snowball Earth. Snowball Earth was 650 million years ago. This was when the world was covered in ice and we had a frozen glacial planet. Evidence includes that glaciers were in all areas of the planet. Glacial deposits, which are unique and easy to spot, help us know this since most glaciers have long since melted. So, another climate time is the Younger Dryas period. Now this is known for its abrupt change. For a while, scientists believed that change would take a very, very long time and that it couldn't occur fast. However, as more evidence has been gained, they have seen that change can in fact occur extremely fast. Around 14,500 years ago, the world was shifting out of a cold period into a warm period. Suddenly, in the middle of this steady shift, the world went straight back to icy and cold. This is the beginning of the Younger Dryas period. The reason it's called the Younger Dryas is it is named after a flower that grows in England and... not England, sorry. Well, it probably grows in England. I meant Europe. I'm sorry. This beauty. Pretty. It is pretty, actually. Pretty pretty. Still exists. But, grows in cold. Anyway. The end of the Younger Dryas was also abrupt and occurred around 11,500 years ago. Evidence shows that parts of the world increased temperatures by 10 degrees Celsius or about 18 degrees Fahrenheit within 10 years. That's really, really fast. For that amount of increase in temperature within a decade, it was massive, and it shows change can occur extremely quickly. This is a good example that climate can change very rapidly from non-human related reasons. However, evidence supports that this climate issue today, is human-caused. This sidetrack is important to note. The last time that the greenhouse effect became unbalanced in this way was during the Permian extinction, when the planet did not release enough heat through the atmosphere. When this happened, the world had many more volcanoes than the world has today. Scientists do know that the CO2 from volcanoes were a major cause. The CO2 today is also the leading issue. We know that the amount of CO2 today is not caused by volcanoes, however, like it was in the Permian era. We know this because scientists, specifically meteorologists, have made observations that show this to be true. They noticed that the number of sun rays reaching Earth and the volcanoes and other natural sources of CO2 and methane gases have not changed much over the time frame of human beings. Meteorologists calculated 3 separate impacts on temperature and what the temperature would be over time. The first calculation considers only human impact, the second considers only solar and volcanic impact, and finally the third calculates the impact of the combination of the two. Through observing for years, they found that the CO2 and temperature of the planet correlated with the human impact and was much higher than the solar and volcanic impact alone. Many argue that humans cannot affect natural processes. However, much as we like to separate ourselves from the systems on Earth of bacteria and animals and plants, we are a part of it. An example of impact one species alone can have is Yellowstone National Park, where removing wolves and later reintroducing them had a major impact. Hunting and other factors led to there being no wolves in Yellowstone for a while. This led to deer eating more of the plants, and although there were bears, they did not eat enough of the deer to prevent the plants decreasing. Some of those plants' roots helped prevent erosion from rivers, which meant rivers began to change directions. In 1995, wolves were re-released into Yellowstone National Park. Soon after, plants regrew back and rivers went back to the paths they used to have before wolves disappeared. The addition of just wolves changed the course of rivers. If wolves could have that impact, we as humans are also capable of causing major change throughout the planet, especially since we greatly outnumber wolves and take up much more of the planet. Our actions, like those of other species, impact cycles and systems which can have unforeseen consequences, whether good, bad, or neutral. By definition, we are animals and part of the system. Dictionary.com states that an animal is a living organism that feeds on organic matter, typically having specialized sense organs and nervous system and able to respond rapidly to stimuli. But this definition isn't the most thorough. It doesn't account for animals such as sea sponges, and that kind of bothers me because sea sponges are freaking awesome. I know they're just sponges, but they're animals that... Anyway, they don't have a nervous system, so they don't quite fit the definition. Anyway, whatever. They're still living creatures. They are animals. Anyway, we are animals too, by that definition. The only reason people have a disagreement about whether or not humans are animals is how you're defining animals. If you define it in the very scientific way of we are beings that live, and like the definition I gave and stuff, then we're animals. But some people will find that offensive because they think animals defines like brute force or instinct only and not thinking, which I also think is kind of rude to other species because octopi are incredibly intelligent and we call them animals, and if you're seeing animals as an insult, then you really shouldn't be calling octopi that, probably not chimps. I mean, certain species of bird are extremely smart, crows are very intelligent. To me, it's either just you're underestimating other species or you're over-putting us on a pedestal. That was a big sidetrack. Point is, we're animals. Okay, and animals have impact on ecological systems like the wolves with the river. Anyway, moving on. Back on track. Ways we are aware that humans are a large cause of the CO2 in the atmosphere are as follows. We know that since the Industrial Revolution, humans have been burning more fossil fuels and cutting and burning down forests to clear land. And we know these activities release CO2. Calculating land cleared and how much fossil fuels we've burned as a species, scientists have found that we have released enough CO2 to raise the concentration to 500 parts per million. Currently, we are at about 380 parts per million in the atmosphere, an increase from 280 parts per million around 150 years ago, at the beginning of the industrial era. That's 100 parts per million increase in 150 years. That's actually quite a lot. The reason we aren't at 500 parts per million is because oceans and forests are able to absorb a decent amount of CO2. Experiment time. Alright, we're going to use some red cabbage and show how oceans absorb CO2. I don't really need to be wearing a lab coat, but I have one, so I felt like it. For experiment number 1, I'm going to show it using vinegar and baking soda. Okay, as you see, I have 2 red cabbage. I know it looks purple, but apparently it's called red cabbage. Red cabbage water, just red cabbage water. In this one, nothing. In this one, a little extra container that I'm going to put baking soda and vinegar in. And this will show change in color because, like the oceans, it'll absorb the CO2. CO2 will change the color of the purple cabbage water. The way we're going to show this and demonstrate it is with some vinegar that I have in here and some baking soda. Baking soda. There we go. Okay. Put a little bit of baking soda in this. Sorry, I don't have the best angle to view this. I tried to find different angles. This is what you get, just eyes. Okay, vinegar and baking soda. Oh, well, it's overflowing a smidge. But it will still demonstrate the difference. There are 2 other cups I've got with purple cabbage water. Let's move these to the side. We'll show the changing color in a bit. CO2. So these are the same color right now. As I blow bubbles with my straw into this one, we're going to see, exhaling CO2, the changing color between these 2. As you can see, dark blue, it didn't absorb any CO2. Much more purple, it did. Dramatic change in color. Dark blue, lighter purple. Just takes a lot more energy, but since we know we breathe out CO2, you can see the absorption. Also, that bottom gunk is because I never sieved out my cabbage water. Alright, hope you enjoyed this experiment. Back from the experiment. Plants grow from the CO2 we breathe out. A separate way we can tell humans cause a lot of the CO2 is isotopes. Isotopes are the same chemical with different masses due to a different number of neutrons in their nuclei. An example is 14C, 13C, and 12C. All are forms of carbon. 12C is the most common, while 13C is about 1%, and 14C is even less. CO2 produced from burning fossil fuels is not the same isotope as what naturally occurs in our atmosphere. Fossil fuels are mainly plants, and plants tend to have a higher proportion of 12C than 13C. They have about a 2% smaller ratio than the atmosphere. This means when they are burned as fossil fuels, the ratio of 12C to 13C in the atmosphere decreases as well. A way to test if the percent of different isotopes of carbon have changed in the atmosphere is through testing tree rings. Trees take up carbon dioxide from the atmosphere through photosynthesis. This means you can look at older rings and check the composition of isotopes for that time and compare it with newer rings. It will not contain exact ratios for what the atmosphere was, but it will show how the ratios changed. Looking at tree rings, it has been found that in the last 10,000 years, the ratio of 13 to 12 has never been this low before. It also shows us that the ratio began decreasing around 1850, the time carbon began increasing in the atmosphere and humans began burning fossil fuels on a large scale. Ice cores also show us the change in atmospheric carbon over time. The ice cores even show the variation in carbon between glacial and interglacial periods, and that the change which took place over thousands of years is 5 times less than the change that has occurred in the last 150 years. Showing it's not just the normal change between glacial and interglacial periods either. Scientists have lots of evidence that humanity is the leading contributor to climate change. Let's examine what it is we are doing to contribute to climate change. Starting in the Industrial Revolution, we began to burn coal and oil at a high rate. These began to add CO2 to the atmosphere. Human causes of increased CO2 to the atmosphere also include deforestation. As I said earlier, plants take in CO2. Less plants equals more CO2 in the atmosphere. The amount of CO2 in the atmosphere has increased by over a third since humanity began the Industrial Revolution. Methane increased due to human trash decomposing, agriculture, and the increase in livestock that produce methane, such as the cows mentioned earlier, as well as rice paddies. Methane is actually a more powerful force than CO2 is with regards to climate change and how much it adds to the greenhouse effect. However, it is a smaller proportion of the atmosphere than CO2. Human behavior and actions have caused many of the problems of climate change that we face today. Let's take a look at CO2 changes over time. This chart, which doesn't have a title, which I don't get because as a biology graduate, I had to put a title to every single chart. Physics, chemistry, didn't matter. I always had to put a title. Anyway, doesn't matter. This chart shows the levels of CO2 in the air over time in the planet. At this section of the chart, it shows that the CO2 increased dramatically in the last 100 years versus what it has been in the last 650,000 years. While CO2 changes over time, just like temperature, today's levels are higher than it has been for thousands of years. These higher levels of temperature and CO2 endanger all of us on Earth. Misconceptions can cause people to underestimate a problem, focus on the wrong part of the issue, or even ignore that a problem exists. If you believe climate change is mainly due to non-human causes, you won't take it seriously enough and you will ignore actions that need to be taken to combat the problem. If you focus on something that isn't all that important, such as the cows producing methane, you will not see where true change should occur. Understanding misconceptions can help to make reasonable decisions. In the past, people believed that riding a train would drive you insane from the speed and motion. If we still believed that, modern cars, planes, and bullet trains would definitely not exist, and transportation would be much slower. Also, in the 1500s, doctors believed blowing tobacco smoke up a person's butt could cure multiple things. Ugh. I would not want to be the doctor or the patient. Terrible. And no, that wouldn't cure anything. Nothing at all. Definitely not. Point being, sometimes what you believe changes over time. Sometimes people learn more, and it's important to take on new information and to accept new facts and data. And not blow tobacco up people's butts. Okay. Anyway, humanity will always have times that we believe something that isn't accurate. The important thing is to pay attention to new information and facts and adjust beliefs to evidence. Back to climate change. It is also important to know the negatives of climate change and the problems that are occurring and could occur in the future. Which brings me to episode 3 that will have dangers of climate change and hope and things we can do to fix it. See you next time. Subscribe or like. Don't if you don't want to. That's fine. Want to. Subscribe or like. All right. See you next time for part 3 of climate change. Sorry, long talk. I mean, I could probably have made it longer. I could make it shorter, but then I'd be cutting out a lot of stuff I think is rather important. See ya.